This video introduces functions. A function is just a special relationship between two variables, usually ones we call x and y, a relationship in which every x value has exactly one y value. In other words, if I put in a number for x, I'm only going to get out a single value for y. I'm not going to get out two different values for y. If I put in a number for x, there's only one answer. There's not two answers. So the notation you see on your screen of f parentheses x close parentheses, that's just notation to indicate that we have a function and the input variable is x. So we're not multiplying something called f by something called x. It's just notation to say we have a function. For this particular function, when we plug in a number for x, we take it and we do 2x squared minus 4x plus 5. So if I want f of negative 3, whatever's in parentheses after the f is the number that gets plugged in for x. So f of negative 3 simply means I'm going to do 2 times negative 3 squared minus 4 times negative 3 plus 5. Notice the negative 3, which was getting plugged in for x, gets squared. So I usually write it in parentheses like that when it's being raised to a power so that I know the negative is raised to the power as well. That makes it a positive 9 times 2 is 18. And then negative 4 times negative 3 is positive 12 plus 5. 18 plus 12 is 30 plus 5 is 35. So f of negative 3 is equal to 35. That means when I plug in the number negative 3 for x, I get out a y value of 35. B, f of a squared. So again, whatever is in parentheses gets plugged in for x. So instead of 2x squared, I'm going to have 2 times a squared squared minus 4 times a squared plus 5. So I replace all the x's with a squared. And then I just simplify it. When I square something that already has a power, when I take something with a power and raise it to another power, I multiply those powers. So a squared squared is a to the 4th because I multiply the 2 with the 2. Minus 4a squared plus 5. There's no like terms there. Can't combine anything. So I'm done. That's f of a squared. What about f of 1/2? Well, that means I'm going to take 1/2 and plug it in for all the x's. So I'm going to square 1/2. And when I square a fraction, I square the top and the bottom. So 1/2 is 1 squared over 2 squared. That's 1 over 4. So I've got 2 times 1 over 4. What is 4 times 1/2? 2. What's 2 times 1/4? Well, that would be 2 over 1 times 1 over 4, which makes 2 over 4, which makes 1/2. Minus 2 plus 5. Well, 1/2 minus 2 is 1/2 minus 4 over 2. That's negative 3 over 2. Plus 5. 5 is 10 over 2, which makes 7 over 2. So f of 1/2 is 7/2. D, f of 1 over x. Well, I'm going to take all the x's and replace them with the 1 over x. And then I'm just going to simplify. Squaring 1 over x means squaring the 1, which is 1, and squaring the x, which is x squared. That 2 times the 1, we'll just put the 2 in the numerator. 4 times the 1 puts the 4 in the numerator. And there we go. F of 1 over x. Okay. How about this function? Oh, that looks a lot more complicated, Mr. Shaver. Why are you doing that to us? This is called a piecewise function. It means it takes on a different value depending upon what x you put in. So this one is in 3 pieces. Each piece is defined on the right-hand side by particular values of x. If x is less than negative 1, then we're going to do 4 minus x squared. But if x is between a negative 1 and 2, including negative 1 and including 2, then we're going to do 3 plus 2x. And if x is greater than 2, if it's bigger than 2, if it's 10, we're going to do 2x cubed. So it's just defining it in pieces instead of defining the whole function by one expression. So g of negative 3. I'm plugging in negative 3 for x, so which piece am I going to plug it into? Well, negative 3 falls into the first category. It is less than negative 1. So the piece I'm going to plug it into is the top piece. I'm going to do 4 minus, parentheses, negative 3 squared. Why parentheses? Because the negative gets squared. So when I square the negative 3, I get a 9. I've got 4 minus 9, and 4 minus 9 is negative 5. B, g of negative 1. Well, which piece does negative 1 fall into? Well, I see a negative 1 on the first piece, and I also see a negative 1 on the second piece. So which one do I use? Well, the first piece does not include negative 1. It's just when x is less than negative 1, not less than or equal to negative 1. But negative 1 is included in the second piece because it says negative 1 is less than or equal to x, which is less than or equal to 2. So it will count negative 1 in the second piece. So that's the one I can go to. I can't go to the first one. So I'm going to plug in negative 1 into 3 plus 2x, making it 3 plus 2 times negative 1. Well, 2 times negative 1 is negative 2, plus 3 is 1. What about g of 0? Which piece does 0 fall into? Well, 0 is not less than negative 1. 0 is not greater than 2. But 0 is between negative 1 and 2, so it falls into the second piece. We'll plug in 0 to the second piece, making it 3 plus 2 times 0. 2 times 0 is 0, plus 3 is 3. What about g of 2.1? Well, 2.1 is bigger than 2, so it falls into the third category. Anything that's bigger than 2 is going to fall into that third category. So we're going to do 2 times 2.1 cubed. And 2.1 cubed is obviously 9.261 times 2 is 18.522. So that's g of 2.1. Finally, domains of functions. The domain of a function consists of all of the values x for which f of x exists as a real number. So everything that I can plug in to the function for x and get out a real number. So get a real number answer. In other words, we have to throw out of the domain any values which cause problems in the function. Right now, 2 common things that can cause problems for our domain are values that make the denominator of a fraction equal to 0, because dividing by 0 makes it undefined. That's a problem. And any values which would give us a negative number underneath a square root, or a 4th root, or a 6th root, or an 8th root, any even root, because we cannot take the even root, including the square root, of a negative number and get a real number. We get an imaginary number, but we're not interested in those yet. We state our domains in this class in interval notation. This provides the endpoints of an interval within which we will accept any number. So it's saying we'll accept x in this range from this number to this number. The interval from 2 to 5, where we're not including 2 but we are including 5, is represented in this form. Parentheses 2, comma 5 with a rectangular bracket around the 5. That means our endpoints are 2 and 5, so anything between 2 and 5 works. So 2.1, 2.2, 3, 4, 4.99999, all that works. So does 5. That's what the rectangular bracket around it represents. But 2 itself does not work. So we use a rectangular bracket when we include the endpoint, and we use parentheses when we do not. So 2 does not work, but anything marginally bigger than 2, 2.000000000000000000001 works. We always use parentheses around infinity. For example, if we will accept all x less than or equal to 4, then when we use the interval starting at negative infinity and going to 4, because it's less than or equal to 4, we'll put a rectangular bracket around 4 because we will include 4. And we always use parentheses around infinity because infinity is not technically a number. It can't be included. But anything smaller than 4 will work. So let's find the domain of each of these functions and write the domain in interval notation. Number 3, f of x equals 3x to the fourth minus 2x squared plus 6x plus 4. So remember, there's two things we need to be wary of. Anytime we have a fraction, we have to throw out any number that will make the denominator of the fraction equal to 0. I see no fractions here. And anytime we have a square root or an even root, we have to throw out any numbers that give us a negative number underneath the square root. I see no roots here. Therefore, any number works. I can plug in any number on for x, I can raise it to the fourth power and the second power, and I can multiply them by 3's and negative 2's and 6's and 4's and add them together. No number is going to cause a problem. So the domain is all real numbers. How do we express that in interval notation? Well, the smallest thing we'll take is negative infinity. And the largest thing we'll take is infinity. So we write it in interval notation like that. Anything from negative infinity to infinity. And again, we always use parentheses on infinity. All right? That one had no problems. How about number 4? G of x equals 2x over x minus 3. Does that have a problem? Well, I see a fraction. That means I cannot have a 0 in the bottom of the fraction. So is 0 the number that's the problem? No, because 0 doesn't make the denominator equal to 0. 0 would make the denominator equal to negative 3, and that's perfectly fine. 3 is the problem. 3 is the number that makes the denominator equal to 0. So x cannot equal 3. We'll just make a little note of that. So we need to make our domain everything other than 3. So we're going to write it as negative infinity up to 3, but with parentheses because we can't include the 3. And then 3 to infinity with parentheses on the 3 because we still can't include the 3. And anytime we have more than one interval, more than one piece to this, we put a U in between them, like a capital U. It means a union. It means we'll take anything in one of those intervals or the other one. Doesn't matter which one. Number 5. H of x equals 3x minus 2 over x squared minus 4x. Again, we've got a fraction. So we have to throw out anything that makes the denominator of the fraction equal to 0. It's going to be helpful if we factor the denominator. How do we factor x squared minus 4x? We take out the common factor of x, making it x times x minus 4. Now that x we took out just sits in the front, it can't disappear. And it's just the 3x minus 2 on the top. We don't care so much about the top, we care about the bottom because that's where the problem occurs. So what numbers make the denominator equal to 0? Well, the denominator will be 0 if x itself is 0 or if x is 4. Either one of those is going to make the denominator equal to 0. So x cannot be 0 and it cannot be 4. So our domain is everything else. So we'll take anything from negative infinity up to 0, parentheses, union. Anything between 0 and 4 works. Parentheses, notice on both of those, union. Anything bigger than 4 works. So parentheses 4 to infinity. That encompasses everything from negative infinity to infinity except for the 0 and the 4. We left those out. That's our domain. All right, how about number 6? Capital F of x equals square root of 3 minus 2x. This time we don't have a fraction, but we have a square root, which means the other problem is happening here. We cannot have a negative number underneath the square root. That means that what is underneath the square root, the 3 minus 2x, can't be negative. So what it needs to be is greater than or equal to 0. Why greater than or equal to 0, not just greater than 0? Because we can take the square root of 0. It's just 0. That's fine. It's when we have a number that's smaller than 0 underneath the square root that's a problem. So we set it greater than or equal to 0, and we solve it for x to figure out what x can be. So I would subtract the 3 from both sides, make it negative 2x is greater than or equal to negative 3. And then I would divide by negative 2, remembering, of course, that when I have an inequality and I divide by a negative number, I have to switch the sign. And I have negative 3 over negative 2 gives me a positive 3 over 2. So as long as x is less than or equal to 3 over 2, we have no problem. So that's what we want our domain to be, less than or equal to 3 over 2. Well, how do I represent that? Well, I'll take anything starting at negative infinity and going up to 3 over 2. Will I include 3 over 2? Yes, because it's less than or equal to. And that's the only piece of my domain, because anything bigger than 3 over 2 is going to be a problem. X needs to be smaller than 3 over 2. Seven. Capital H of x equals 2x minus 5 over radical x minus 8. This time I have a fraction and I have a square root. So we're still focused on the denominator of the fraction, that radical x minus 8. I know x minus 8 is going to need to be greater than 0, but I don't want it to be equal to 0 this time, because if it was equal to 0, because it's in the bottom of the fraction, it would cause a problem. If x was 8, and I plug it in, then I don't have a problem underneath the square root, but I have a problem in the bottom of the fraction. So this time I just took what was underneath the square root and made it greater than 0, because being equal to 0 makes the fraction undefined. So if you have a radical in the bottom of the fraction, just take what's underneath it and set it greater than 0, strictly greater than 0, not greater than or equal to 0. All right, so x minus 8 is greater than 0. That means x is greater than 8. That's my domain. In interval notation, that means I start at 8, but I don't include it, because it's just greater than 8, and I go to infinity. All right, how about number 8? The fourth root of x squared plus 3x minus 10. A fourth root is an even root. Any even root, like 4 or 6 or 8 or 10 or 12 or 32, has the same problem as a square root. So we cannot have a negative number underneath this fourth root. But what I have underneath the fourth root is a quadratic expression, x squared plus 3x minus 10. I want that to be greater than or equal to 0. The only way to solve that is to factor it. It gives me x plus 5 and x minus 2. And the only way to solve that, I cannot take each one of those and just set them greater than or equal to 0. I have to think of it as a number line, and put on that number line the two values that make it equal to 0, which would be a negative 5 and a 2. I will allow it to be negative 5, so I'll put a closed circle there, and I'll allow it to be 2, because I'll put a closed circle there, and that's because it's greater than or equal to 0. And I'm going to pick a number in each of those 3 sections that I've now made on the number line, and plug it in and see whether it's positive or negative. So I'll take negative 6, that's in this left section, the one to the left of negative 5, and I plug it in. It gives me negative 6 plus 5 is negative 1. Negative 6 minus 2 is negative 8. When I multiply negative 1 times negative 8, a negative times a negative is a positive. So I'm going to mark that section of my number line as being positive. Now if I pick a number in between negative 5 and 2, an easy one to pick is 0, and I plug it in, I'll get 5 times negative 2, which is negative 10, so I'll mark that section as being negative. And if I pick a number bigger than 2, like 3, and I plug it in, I'll get 8 times 1, which is positive 8, so I'll mark that section as being positive. Now I want this to be greater than or equal to 0. That means I want it to be positive. So I will take anything in these positive sections of my number line, to the left of negative 5 and to the right of 2. So now I'm going to express that in interval notation. I will take anything to the left of negative 5. That means from negative infinity up to negative 5, including negative 5, because it's greater than or equal to 0. So I put, because I had the closed circle, I put the rectangular bracket at negative 5. Union. I will take anything starting at 2, including 2, and going up to infinity. That's my domain. So it's helpful to make that number line, and then I can just translate that into interval notation. Last one. Capital G of x equals 4x over the fourth root of 1 minus x squared. Again, fraction, and a radical on the bottom of the fraction. When that happens, I take what's in the bottom, underneath the radical, the 1 minus x squared, and I simply set it greater than 0. because if it was equal to 0, it would make my fraction undefined. So I solve that, but I notice that x is squared. My only way to solve it is to factor. How do I factor 1 minus x squared? Well, it's a difference of squares. 1 minus x times 1 plus x. And then I have to make a number line since I factored. And I put on the number line the two values that make them equal to 0. That'd be a -1 and a 1. Put open circles this time, because I don't want it to be equal to 0. I only want it to be greater than 0, so I can't include -1 or 1. That's divided my number line into 3 sections. I pick a number in each of those 3 sections, plug it into that factored expression, and see if it's positive or negative. So I pick -2, plug it into this factored part. 1 minus -2 is a positive 3. 1 plus -2 is a -1. Positive 3 times -1 is a negative number. Mark it as negative. Go in between -1 and 1, like 0. Plug it in, I get a 1 times a 1, which is a positive 1. Mark it as positive. Pick a number bigger than 1, like 2. Plug it in. 1 minus 2 is -1. 1 plus 2 is 3. -1 times 3 is a -3. Mark that section as negative. I want it to be greater than 0. I want it to be positive. That's only going to happen in between -1 and 1. So how do I express the domain? I express it as the stuff that starts at -1 but doesn't include -1, and ends at 1 but doesn't include 1. So what's in there? Is it just 0? No, any real number is in there, like 1/2, 1/3, 5/9, 0.62. All of that's in there. An infinite number of numbers are in there. And that's how I express them, from -1 to 1.